Welcome. In this clip, we discuss functions. Function can be seen as a rule which establishes relationship between at least two factors. We usually denote these factors, in general, as y and x. So, what a function does is establishes a rule which helps us to establish a relationship between the two factors. Or this rule can also be written as f of x. And the rule between y and x, the rule of the relationship between y and x, is in general denoted as f of x. Of course, this f of x may take some particular form, a functional form. For example, if y is the length of an individual in centimeters and x is the length of an individual in inches, then to establish the relationship between these two, we could write that y equals 2.54 times x. But of course, there are also other more complex functions which are going to just make possible to describe some phenomenon in society, economics, and generally in life. For example, one of these could be a logarithmic function, or it could be a quadratic function, which are nonlinear functions. Quadratic function would look as a, which is a constant, plus b times x plus c times x squared. And this would be what we call quadratic function. But you could also call it a second-order polynomial. In order to find out how we can use these functions in economics, let us draw them first. Let us start with the simplest possible function. Y equals a constant. Now, we can simply depict this in a standard Cartesian coordinate system. A is a number, and what this relationship says, that independently of the value of x, y will always take the same value, namely a. So this is a lack of relationship between y and x. Another possibility is that we have a linear function like this, where a and b are just two numbers. No, we assume that a is bigger than 0 and b is also bigger than 0. In that case, our function will look as follows. That is, this will be the a plus bx function, and this will be function a. And you can already see that the slope of this function is going to be b, which means that if you move to the right along the x-axis by 1 unit, then the value of y will increase by b units. And we could also draw a logarithm function. For example, y equals the logarithm of x, which here denotes the natural logarithm of x. Now, the value of logarithm of x is not defined when x is 0. So it means that there will be a point, namely when x equals 1, when this particular function will take a positive value. And if the value of x is between 0 and 1, but it is not equal to 0, then you will have negative values for y. And actually, then you can draw this function as something like this. But how to depict a function which is quadratic? Now let's assume that a is a positive number, b is also a positive number, but c is a negative number, and furthermore we can also assume that in absolute value b is bigger than c. So what happens here? If you look at this functional form, then you can observe that the first part here is a linear function just like above, just like this one. And here you have a nonlinear function, and this nonlinear function is going to become more and more important as you increase the value of x. So initially, when x is 0, you will again start from this point. When x is still low, x and x squared are relatively similar. So that means that the first part, b times x, is going to dominate the relationship. So initially there will be a increase in y as you increase x, but when x is very large, then this second nonlinear negative part will become much bigger than the b times x. And as a result, you will then, after a while, get the second part dominant, and the value of your function will decrease, and you will have an inverted U-curve relationship. What if we were changing this, and y, a is still the same and above 0, b is no negative, and c is positive? Well, in this case, initially, the negative part would be dominant, but after a while, the second part, positive part this time, would dominate this relationship, and then you would get a U-shaped curve. Now, these functions will be the most important functions that you will encounter in introductory level economics course, and these will be very useful to describe certain relationships. For example, the inverted U-curve relationship, so the green line, could be a relationship between an amount of goods you consume and the total benefit you gain from consuming that particular good, which we call in economics utility. And indeed, if you just start to consume your first unit of this good, then you will experience a relatively large change, a large increase in your benefit. As you increase your consumption of the good, the extra benefit will slowly decrease, and there will be a point, somewhere here, when actually you have no further benefit from consuming an additional unit of x. This is what you could call the saturation point. And this is also the maximum utility you can gain from consuming the good. But if that person were forcing you to consume even more, even after you already reached your saturation point, then the overconsumption would actually cause you discomfort and would reduce your utility. So, in this case, there would be a point after which the product X would not be called good anymore because it doesn't do any good to you, but rather a bad. Of course, no reasonable person would, out of free will, ever consume more than the saturation quantity of a good. But of course, under duress, it is possible that someone overconsumes.